In this video, we're going to talk about a factoring method called a difference of squares. And so this is a special case that we will find when we are trying to factor our quadratic expressions. So the expression has two terms that are subtraction or difference of two terms that are perfect squares. So for example, a difference of squares would be x squared minus 25, because x is a perfect square because it's x squared, and 25 is a perfect square because 5 squared is 25. And so that would be an example of something that is a difference of squares. And we actually have a specific formula for difference of squares, and it says that a squared minus b squared is equal to a plus b times a minus b. So looking at this example above, that would mean that this x squared minus 5 squared would be equal to x plus 5 and x minus 5. And another thing to note, if there is a coefficient but no GCF, they are probably both perfect squares. So let's look at a few examples. So first I have x squared minus 4. I see that I can rewrite this to being a difference of squares by having this be x squared minus 4 is the same thing as 2 squared. And then from there I can go ahead and write out my factored form. So that's going to be the same thing in both x and 2. The only thing that's going to be different is one's going to be plus and the other is going to be minus. Okay, let's look at the next one. I have x squared minus 49. Well, I could rewrite that to be x squared minus 49 is the same thing as 7 squared. And if you don't automatically recognize what these are equal to, these squares, another way that you can figure that out is when you go in your calculator, you can just type in the square root of 49. And when you take the square root of 49, that's equal to 7. Okay, and then from here, I'm going to have my factored form. So I have x, 7, x, 7, and then one's going to be plus, and the other's going to be minus. Okay, number 3 and 4 look a little bit different. So for number 3, I have 25x squared minus 36. So this time I have a number in front of my x squared term, where the other two I didn't. And I see this doesn't have a GCF. There's no numbers that go into 25 other than one that also go into 36. However, I do recognize that 25 is a perfect square. 5 squared is equal to 25. So I can rewrite this first term to be 5x quantity squared. And I can check to see that is equal. Well, 5x squared is the same thing as 5x times 5x, and I do get 25x squared, so I am good. And then 36 is 6 squared. And so writing that in factored form, I get 5x plus 6 times 5x minus 6. Let's look at one last one. So here I have now two different variables, x and y. And I have 100x squared minus 81x squared. Well, rewriting this first term, 100, I know that's 10 squared. And then x. So I can rewrite 100x squared be 10x squared. Minus square root of 81 is 9, so this can be the same thing as 9y quantity squared. So writing this in factored form, I get 10x plus 9y times 10x minus 9y.